Okay, we're starting to work with circuits with more than one resistor. We've done series and parallel circuits. Now we're going to do more complex circuits where it's a combination of series and parallel. The way to solve these is usually to first find the equivalent resistance for the whole circuit. Step 2, use the loop rule and the junction rule to find voltages and currents. Okay, the loop rule goes with voltages and the junction rule goes with currents. So here's an example. I need to find voltage, current, resistance, and power for each resistor in this circuit. So I'm going to start this way. Find the equivalent resistance, the total resistance. So I have the 4, it's in series with this combination of the 12 and 8 that are in parallel. So first I'm going to deal with that parallel. So 1 over R parallel is 1 over 12 plus 1 over 8. Common denominator would be 24, so this would be 2 over 24 plus 3 over 24 is 5 over 24. Now that's 1 over R, so to get R, I have to take the reciprocal, so 24 over 5. So the parallel resistance is going to be 4.8 ohms. So these two together are like having one 4.8 ohm resistor in there. And then that 4.8 ohm resistor is in series with the 4. So to get the R total, since they're in series, I could just add them up. So it's 4 plus 4.8 is 8.8 ohms. Now, since I know the total is 8.8, I can do V equals IR. So V total is I total times R total. So 12 is I total times 8.8. I want to divide that out. I'm going to get a value for I total. 1.36 amps. So I'm going to actually draw that on here. I know the current coming out of the battery, the total current here, I, is going to be 1.36 amps. Now, if you want to make a curve chart, you can. VIRP, total, and I have 3 resistors. I can start filling some things out on here. Now, my R1 was 4, R2 is 12, R3 is 8, and then my total I found over here was 8.8. Excuse me. Now my I total coming out of the battery was 1.36. Okay, and that gives me a V total of 12. Now, here's where it gets a little bit trickier because it's not series or parallel. In parallel, all of these are the same, but it's a combination, so I can't assume that. In series, all the I's are the same, but it's a combination, so that's not going to be true everywhere. But I have to start thinking about what's going to be happening. Well, this 1.368 or 1.36 amps of current that's coming out of the battery, the only place it has to go is through the 4 ohm resistor. So kind of by a junction rule, if I think of this point as a junction, I got 1.36 going in, 1.36 has to go out and go into that 4 ohm resistor. So now I know that this is 1.36. Now I can find the voltage there, again, V equals IR. So V is 1.36 times 4, and that's going to give me 5.44 volts. So I'm going to put in here 5.44. Now, I know that when my 1.36 is getting to this point, but then it's going to split into 2 different currents. And I don't know how big each one is. But what I do know is this. If I do a loop rule for my voltages, I'll be able to get someplace. So I know this is 5.44 here. Now the loop says the voltage in the resistors has to add to the voltage of the battery for any loop I take. So let's say I do the left-hand loop. I'm going to kind of draw this in green. I'm doing this left-hand loop right here. All right. From that, I know that 12 has to equal 5.44 for the first resistor plus whatever the voltage through the 12 ohm resistor is. Because that's the only resistor I go through if I do that loop. So that means the voltage for the 12 ohm resistor is going to be 6.56. Now, I'll get the same thing if I do the outside loop, okay? If I go through the outside loop, I gain 12 in the battery, and then there's 5.44 in the first resistor, then I only go through the 8 ohm resistor, so it's going to be 6.56 there also. Now I know V's should be the same in parallel, and these two are in parallel with each other, so those V's are going to be the same. Now I can find those I's by doing V equals IR again. So I just divide 6.56 divided by 12, and I get 0.55 if I round. And then 6.56 divided by 8, and I get 0.82. Now, there's a check here. What I notice is, all right, whatever current here, the 1.36, gets split into those two at this junction. So those two going out have to add up to the 1.36 going in. And if I do that, I get 0.82 plus 0.55, and I get 1.37. Now we've done some rounding, so that's why they're not exactly the same, but it does check out. Now for the powers, I just do P equals VI. So I'm going to multiply each of those out, and I'll write the results. So those values are 16.32, 7.40, 3.61, and 5.38. And my check on those is these three should add up to 16.32, and with differences in rounding, they do. We have one more problem that's similar. Okay. For this one, again, we're going to find our total. Now this time, we have these two are in series, and then that series is in parallel to 24. So for this one, what I'm going to do is find the R series is equal to 3 plus 9 is 12. And then our total I'm going to find by doing 1 over our total is 1 over 12 plus 1 over 24. That's going to give me my common denominator is 24, so 2 over 24 plus 1 over 24 is 3 over 24. Now remember, that's the reciprocal of the total, so our total is equal to 24 over 3 is 8. So now I know this whole mess is equivalent to one 8 ohm resistor. So now I can do V total is I total times R total. So 120 equals I total times 8. That gives me a total current of 15. So now I know my current coming out of here is 15 amps. So I go ahead and make my chart. Okay, I get the following. V total is 120. I'll call this one R1. R1 is 24. And this one's 2 is 9. And 3, my total is 8. And then that gave me a current of 15 coming out of the battery. Now last time, I just took that current and it was all going into the first resistor, but now that 15 is going to get to this point and it's going to split. So these two are going to add to 15, but I don't know what each one is. So where am I going to go from here? The trick to this one is if I do my loop rule just for the left-hand loop and I go around here, okay, the only resistor I'm going through is a 24 ohm resistor. So the voltage for that has to be the same as the voltage for the battery. So I know that this is 120 here. Now I can find that I, V equals IR, so I times 24 equals mu 20. So if I divide that out, 120 divided by 24, I get 5. So now I know I had 15 coming in here, 5 go this way. How much has to go the other way? By the junction rule, those two outs have to add up to 15, so this has to be 10. Now if I have 10 going into the 9, 10 has to come out of the 9 and go into the 3, so this is also going to be 10. Now we can find these voltages. 9 times 10 is 90. 3 times 10 gives 30. They add to 120, and that makes sense because if I do the outside loop, okay, I get 120 volts from the battery. I have the voltage for the 9 and the 3 have to add to 120, and they do. Now finding the powers, I just multiply V times I. And if I multiply those out, I get 1800, 600, 900, and 300. And my check again is all of the powers have to add up to the total, and they do.